All right. Hello, everybody. Welcome to JChampionsConf and this session with Oliver Drotbohm. And I'm very happy to have you here, Oliver. I really look forward to this session. As all of you know, he's a Java champion. He works at VMware, and he is going to talk about architecturally evident Java applications with jMolecules. So, Ollie, the stage is yours.
Thank you, Gunnar, and thanks for having me at the conference. As already stated, this is the topic I'm going to talk about, and we're going to spend the next 60 minutes roundabout on the topic and see what we can have here. Let me just briefly click into this. There we go. So my name is Oliver Drotbohm. I work for VMware. I've been part of the Spring engineering team for slightly more than a decade now. I started as a consultant actually, but very quickly moved into the engineering team and have spent a lot of time of these 10 years developing the Spring Data projects. So if you've seen the Spring repository data access programming model, then that's kind of has been developed with the team that I've worked in. I've moved into a slightly different role recently, but it's kind of driven by the same interest that spiked the data projects in the first place, because repositories, the Spring Data repositories, were an architectural pattern that we try to provide an implementation for that you can run on either a Spring application or even as a CDI extension. So it was always about making this architectural pattern or implementing that architectural pattern and making it easy for developers to use it and create that architecturally evident code, or that be able to represent that architectural pattern in your code base. And that's kind of what has spiked the work that I'm going to tell you or talk about. Right, that's kind of the backstory. There is a lot of the stuff you hear today is going to also be summarized in a book called Monolithic Applications with Spring, coming around mid-year, early mid-year. So it's going to be like centered around like developing applications with Spring and taking a deeper look at, you can do that in a monolithic fashion, so not like in a distributed fashion, but still building your monolith, but in a well-structured way and with all the with all the Spring technologies that can help you actually doing that properly or better than you may be used to. So let's start with why. Why should you be interested in that topic of architecturally evident Java applications? So I'd argue that we want to build evolvable systems. So why is that? Why do we do that, or why do we want that? If you look at like how developers or teams approach new technology these days, or they get new technology marketed, it's most often about the fact that you get shown that you can build something very quickly, right? So the primary focus is about building a new application, a new REST web service, or sorry about that, a new web application, a new web service, what have you, right? So that's supposed to be productive, easy, quick, what have you. Unfortunately, most of the time that developers actually spend is not building a new system, but actually maintaining systems, right? Changing existing code, hopefully working existing code, adding new features, and what have you. So it's kind of interesting to have a look at what you actually need to be able to do that productively. Right? And there's two primary concerns and two primary aspects that play into this. First is the topic of understandability. So unless you can actually understand a certain code base, a certain piece of software, a system overall, you're not going to be able to change it, right? You have to understand it not as a whole, not entirely, but the part or the individual parts that you're supposed to change, or like have to contextualize that, right? How does that thing you have to change fit into the bigger picture? So it's different levels of granularity, different levels of the need to understand that particular piece that you're looking at. There is, let me take a step back. There's a lot of literature around that. First and foremost, there's a book by Carola Lienthal on sustainable software architectures, and also very recently one by Feline Hermans, The Programmer's Brain, that I can highly recommend. They speak or have basically investigate the psychological mechanisms behind like what makes code understandable. We come to that back in a second. The second thing is evolvability. So once you've understood the parts of the code base, or the project itself, to some degree, you still can only change it if the thing you want to change is actually amendable, right? So if the code is rigid, if there's like a ton of dependencies like from one component to others, or it's that big ball of mud that everyone is so complaining about, then that's going to be hard, right, to actually change the thing. But it's understandability first and evolvability kind of second. So in the books that I mentioned, both Carola and Feline actually point out the topic of chunking and patterns as primary means to basically approach complexity, right? How do we deal with complexity, with complex systems? And it comes down to using well-established patterns. Like it doesn't ultimately come down, but one aspect of it is establishing patterns, architectural patterns, and because we can then talk about the system in a more coarse-grained way, right? We can assign roles to certain parts of the software, and then basically define rules of how they actually have to interact or should interact. But what does that even mean? So how do people approach that usually? There is a very interesting paper by two guys, Eden Kazman, on it's just called Architecture and Design, which is a bit of a generic term, but there's the link to that in the very back of the slide deck. They separate like extensional architectural elements from intentional ones. Sounds complicated. Extensional ones are the ones where you kind of list the things explicitly. So the system consists of different components and modules, right? You can talk about, okay, something is an invoicing module or a shipment module. And the nice thing about these extensional elements is that they very easily transfer into the technological artifacts that we use during software development. We can have an invoicing module, and that could be a deployable, or it could just be a build module that actually feeds into a deployable, or it could be a package within a build module. But there is easy means to assign the logical thing to something technical, right? The same goes for the domain language. I mean, there's also like different levels of sophistication here. As Java developers, we are used to creating types that reflect the domain language, value types like email address or zip code or what have you. We name our methods according to terms in the domain fields. So again, there's a direct mapping, and you explicitly talk about these things. You list them. That's why they're called extensional. There is the intentional elements are more tricky, and well, not in themselves, but in the way that they are actually translated into the code base. What are intentional elements? They are described like as concepts and as rules that those concepts have to adhere to. A very prominent, and that's the one we're going to stick with for the presentation, is the domain-driven design building blocks, right? Things like value objects, entities, aggregates. You've probably already all seen the Blue Book, and you have encountered those terms. That's kind of the intentional elements in the small. But there's also things like architectures, different architectural styles, layered architecture, onion architecture, these kinds of things, right? You're not like, you basically describe, okay, there is a presentation layer or a service layer or a persistence layer, but that's not kind of like directly mapping into your domain, but you rather assign certain parts of your domain to those concepts. And how does that assignment usually work? Like without anything special at hand, teams have resorted to naming conventions. maybe using annotations already, but yeah, that's it, right? So that's kind of the starting point here. So how do we actually, or let's have a more detailed look at it and an example, and like what the different parts or moving parts that play into this actually are. So first, there's of course our user code, right? So we have the code that we write, and we can basically craft that in a certain way, and there's certain traits that we want to see the code that we write fulfill. We don't want to technically overload it with or technical details, right? As an example of that, you don't want to have let's say Spring app types or annotations leak into your domain code. That's usually frowned upon. You want to avoid that. You want to keep your domain model separate from technical details as much as possible. That's of course not entirely possible, because just by the mere fact that we've decided to write our software in Java, we actually already kind of have made a decision to project our logical module onto some technological platform. So we've already decided, we're going to use for example, Java date time types, a local date and whatnot. So we express those model elements in Java and already have done some technical coupling, really, to the Java platform, that is. On the architectural level, as I said, we have these concepts. So you basically decide for whatever pattern language that kind of emerges in your domain, or use one that that is for example, the DDD building blocks, where you, for example, have aggregates, entities, and to stick with an example here that's going to follow us through the presentation, we have an order that consists of line items, and we define order to be an aggregate. For those of you who have not, let's say, deeply read the Blue Book, the responsibility or an aggregate is basically a collection or a group of entities, not a collection, but a group of entities, related entities, that where one of them is an aggregate root. And the responsibility of the aggregate is to enforce some kind of business rules, consistency rules mostly. So let's say we want to enforce that the order has to have a certain amount of minimum order value, right? So the number of line items multiplied with the price, and those summed up has to, let's say, at least exceed a value of 20 euros or something, right? So that's kind of stuff that we can then implement within the order aggregate and consistently write back to the database. Those aggregates can have relationships, and there's a couple of rules assigned to aggregate relationships. So, for example, or take a different example, a value object must not depend on an entity. These kinds of things, and the value of actually assigning those roles to your model elements is that you can then reason about the validity of your model in the first place. And it also helps you understand the code base in a slightly, or in a better way. We're going to see that in a second. So with the concepts and the rules applied, we can already see, or we can logically see that the model that you've just seen here is wrong, not necessarily from a business point of view, but from the point of view of following the patterns and the pattern language, right? So in this case, we were referring to the customer that placed the order as an entire aggregate reference. Like there's the customer attribute there in the order class, and in this case, it's Vaughan Vernon's book on implementing domain-driven design. That's a bad idea. I'm not going to go into the details why necessarily. That would be a topic for a talk on its own, but it's recommended that you rather only refer to another aggregate via its ID, right? And with the roles assigned to the individual types, you can actually could detect these kinds of problems in your implementation, right? So to complete that, how do folks or teams, or how do we see teams actually trying to work with those ideas? And what actually plays into this is the use of technology. So And that comes in two flavors. One is the use of frameworks like JPA, Spring Framework, or have it Jakarta EE frameworks applied that kind of tip their toes into those pattern languages, right? Spring Data had the repository abstraction. JPA talks about entities and whatnot. And they're actually used inside your application. And there are certain heuristics for how you can detect, based on the framework usage, what kind of stereotype or what kind of role a certain class, for example, is. To give you an example here, like there is this kind of heuristic or rule that an aggregate is the primary anchor of persistence. So entities that are managed via a repository are considered logical aggregates, right? That's kind of if you just like for every entity class, JPA entity class that you have in your project, you create a repository, you kind of miss the point. Actually, in the example I've showed you before, line item would never see a repository on its own because order is the aggregate root, and we're only supposed to load orders in their entirety. So that'd be an order repository, and then by inspection from the outside, I could detect, there's an order repository, so I know that order is an aggregate. You see, that's a very indirect way or implicit way of not really expressing the framework, but the concepts, but they're kind of already there. They're just not explicitly there. And what teams then do if they're interested in that kind of stuff, they actually use tools like JQ Assistant, which is as the name suggests, quality assistant tool for Java projects that allow you to parse the entire application, write some configuration code that will identify the concept by referring to JPA or Spring concepts or what have you, and then apply rules to them. Another one is ArcUnit. We're going to see that in a bit as well. That has a more Java-ish or Java development kind of approach to it. So that's kind of the landscape. To complete this, the picture, like for applications that are or teams that are interested in that kind of topic, how they do that these days is the following. You have your application code. The concepts live sort of on the side of the tooling because you have to use the tooling to tell or customize the tooling to describe the concepts. And also the same applies to the rules. And the means of definition for these concepts and rule identifications are like the usage of technologies, of frameworks in the user code. And it's the responsibility of the developer to actually write those definitions. Which is kind of like if you start a new project and you say, okay, I want to buy into that, let's say, DDD pattern language, you shouldn't be busy with, defining how do I identify aggregates in my code base in the first place, right? That's kind of, you should supposed to write business code and actually implement the model that you want to implement. So what if we change that a bit? If there was a way to actually tie these concepts to the user code in the first place, then the responsibility of the developer was to actually just like declare them in the code, right? And we could have tooling provided or prepare the identification just because that detective there already exists. And we could then have the tooling also prepare the rule verification based on what's expressed in the detective. And we could even go ahead and maybe provide some of the framework integration that we need at the boundaries of our application, right? If it comes to persistence or APIs or what have you, based on the expression of these concepts in our actual code base. So what is that detective? It's actually it's a project that I've started with a couple of fellow developers. We've been at conferences and been discussing exactly these topics for over a year now. And it's Henning Schwentner from WPS in Hamburg and Stefan Pirnbaum from the JQ Assistant team, actually here in Dresden. And we've coined this thing called jMolecules. And the idea is that we would want to provide programming language specific means so that you can actually express these architectural concepts inside your code base and then build the integration that's needed for documentation, for verification, for technological platform projection, like make this stuff work in Spring Framework, make this stuff work for JPA, based on that, right? So it's called jMolecules because there is, or there are these kind of means and these integrations for Java, PHP, .NET already. I have to admit that because I'm mostly working in the Java space, the Java port, which is called jMolecules, is the most advanced of the three, right? For the others, the concepts, the ability to express concepts exists, but all the integration that I'm going to show you is not by far not as sophisticated yet. And we're a Java conference anyway, so let's get started, right? So what's in jMolecules? There are annotations and interfaces for you to express the DDD tactical and strategic patterns. Tactical is everything entity, aggregate, value object, factory, service, what have you. Strategic is module and bounded context, basically. So you can annotate your packages, you can annotate your types if you want to. There's also, especially for the tactical patterns, there is an interface-based alternative to that, because using generics, you can already put a lot of these verification rules into the type system, and by that use the compiler to like kind of detect that you've not, or that you've kind of tried to model something that's not valid according to the rules assigned to the concepts. We're going to see primarily the interface-based flavor here in the presentation. Is the logo a caffeine module? It is indeed, and that is for a reason, right? So it's because jMolecules here. So events, it's kind of just the same, very same annotations interfaces to declare a type to be an event to be published, right? And we're going to see more of that in a second. And then there's this entire space of the ability to express architectures. That's mostly annotations because they very likely go to packages, or you can also annotate types to belong to, for example, a certain onion ring. Both we have a classical and simplified flavor of that, but that's probably too much detail already. There's support for layout architecture, and we've worked with the Axon team on support for like CQRS and event sourcing applications. So there's annotations to annotate a command handler, an event handler, and what have you. Right. So the idea is that you use this abstraction. It's a very thin library, right? It's just annotations and interfaces in those core libraries. That you use these types in your application code, and then we can kind of, from the expression of those concepts, we can kind of let everything else flow from that. Right. We can make sure that a class that's annotated with the jMolecules add service annotation becomes a Spring Bean at some place, or a CDI component, or that an add command handler annotated method can actually, if you're using Axon, become an Axon command handler. Right? So you're kind of decoupling from the actual technology that's used at runtime with those annotations. And it's another aspect of that is that jMolecules is focused around just expressing these architectural things, right? There are add repository, or there is add repository in Spring Framework. There is add service in Spring Framework. There's even add controller in there. But Spring Framework is not in the business of defining all sorts of architectural stuff. It just defines annotations for the stuff it's interested in, understandably. And again, not everyone is using Spring Framework. I don't know why, but yeah, just kidding. All right, so we have this jMolecules thing available, like a jar that you put on a class pass. You're going to see that in a second. And you equip your code with it. So that sounds pretty, so simple that it's kind of like, okay, this now enables, right? It's kind of just an enablement drug basically here. So we have more expressive code in the first place. I'm going to discuss this in a second. We can actually verify the expressed model against the rules associated with the concepts. We can derive documentation about the system, reasonable documentation, and we can even eliminate a lot of boilerplate code when it comes to the integration at the application boundaries, like persistence or APIs. Let's take the example again, that aggregate arrangement, and start with the topic of expressive code, right? So this is what a usual, like a classical implementation. It's of course a bit simplified, and but this is kind of what you usually see this stuff boil down to in a code base, right? So you have the order class that's becoming, a JPA entity, and it contains a reference or a list of line items, the reference to the customer. So we already do the right thing here, refer to it via customer ID, and then we have a dedicated order identifier class. Excuse me. So there is already, I'm coming back to, whoa, there's a lot of annotations here in a second. But let's start with the fact that there's no really indication that order could be, is an aggregate root, right? So if you just skim through a code base and find that entity, you now have to basically follow the train of thought that I laid out before. Is there potentially a repository for that? So you have to look for an order repository. How do you know it's even named order repository? So what do you actually look for, right? If we add, or if we augment the code base with the jMolecules types, we can actually move away from that and clarify that code here. Let's do that, right? I'm getting ahead of myself. If you, in this code base, you want to use JQueAssistant to identify the aggregate, you have to go ahead and write that cipher here. Details not the point, but you have to manually come up with some configuration that identifies the concept. It basically says, find a Spring Data repository, inspect the generics, and then find the type it's managing, and all of those types that you found there are aggregates. And then there is also the point of declaring the actual rule that I mentioned before, that aggregates must not refer to other aggregates in their entirety, and that's kind of stuff you'd have to write yourself if you wanted to apply these rules and concepts to the code base that you've just seen. Gunnar, we have a question.
Yes, right. There's one question exactly. So does all this require? Does it require using JPA?
I've lost your audio technically, but I see the question. Does this require using JPA? Not at all. I just used the JPA as the poster child example, because like literally most of the code I see out there is using JPA as the persistence mechanism. It's basically just, okay, here's the thing I want to look at. It's just jMolecules is not tied to JPA at all. There's integration with JPA. I'm going to show you that in a second, but that's just the example here to find something. All right, Gunnar's gone again, so we can continue. You're welcome. So if you use ArcUnit, that just looks the same, right? The point I'm trying to get across here is, if you don't have these concepts expressed in your code base explicitly, you have to do a lot of extra work to apply these verifications, and that's why teams understandably shy away from it. So how can we make this easier? We can actually use, so to summarize, architecture concepts only implicitly expressed in the code, and it's the developer's responsibility to actually do any of this, right? And also tool specific. So if you decide for JQA, then you define all those rules and concepts in JQA way. If you use ArcUnit, it's kind of, you constantly have to redo the stuff unless you're sticking to the conventions that you have applied in one project and take them to another. Now, getting to the meat of it, we can actually go ahead and just refer to the jMolecules, in this case, jMolecules DDD jar. The jar files that we publish are kind of shaped the way that I've outlined the boxes before. So there's jMolecules DDD, jMolecules events, what have you. So you basically pick the pattern language that you want to use, and then you use the types in your code base. So you actually go ahead and at your order implement aggregate root. There's a self-reference. I get to that and get to why that is needed in a second. And you basically already express that the aggregate root has an identifier type of order ID, and there's already like this kind of generics coming into play. The second type parameter of aggregate root needs to be a type that implements identifier, so that you kind of nudged into making your identifier class also implement identifier here, right? And that already, I mean, it's totally straightforward, simple as hell, but it already, like, if you look at the class, there's no guessing what kind of role order plays. Is it an entity that's just contained in some other entity, or what is it? No, it's an important one. It's an aggregate root, and you don't have to go anywhere else to actually understand that. It sounds like very like basic, but it's kind of helpful. And of course, we can now, given that information is in the code base, we can actually and we have prepared all that architectural verification that I've showed you that you'd have to come up with yourself otherwise in both jMolecules, so-called jMolecules integrations project, or in the case of JQ Assistant, it's built into JQ Assistant right away. So if you're using that, you just add the jMolecules plugin down there in the dependencies section, run your jMolecules report, and it would automatically find out that your order refers to a customer, and it actually shouldn't, but rather refer to it to a customer ID. So you get all of this kind of stuff for free. For JUnit, it's just looks like this, right? It's like a test-based, or the verifications are usually run in a JUnit test. It's like slightly, I mean, you can have different kind of preferences between those tools. I'm kind of undecided. I like the fact about JUnit that it's kind of, okay, it's just a standard JUnit test, right? I can just write it. But JQ Assistant is much more powerful because it can also do other things like scanning Git repositories and whatnot. So once your rules exceed a certain sophistication, then it might actually be more of a it might be more on the JQ Assistant side. But I don't want to take a side in here. That's kind of it, right? So it's literally 2 lines to verify the DDD rules across your module in your project that you kind of have to put there. That's sort of it. So verification of the module made easy. Let's get to documentation, and let's slightly zoom out for a second, right? We have our orders module, and if you're likely to know the C4 model for visualizing software architecture by Simon Brown, it's a for zoom details or level approach to architectural diagrams. You have the context diagram, the containers diagram, containers meaning logical containers, not necessarily Docker containers, a components view, and a code view. And as we're talking about application code, we're kind of working in the level 3, level 4 area here. It's very likely that the diagrams for the levels 3 and 4 change pretty quickly. I mean, I'm not sure if you're in companies that require manually or maintained UML diagrams or what have you. Often companies have moved to like trying to extract those diagrams from the code base, which is kind of like also often ends up in too detailed diagrams and what have you. So there's like, especially if the code changes quite a lot, it's kind of in a task that's very hard to achieve or to fulfill properly, because you have continuously having to to catch up with the changes is a lot of effort. But we can actually use the fact that we've expressed these architectural details in our code base to like create these diagrams or extract information and provide some kind of documentation that helps us understand our modules, our context on those levels 3 and 4, basically. So if you think, we've seen an aggregate model from within an order component. So what's kind of interesting if you look at a logical component in the first place, whether that's a package, whether that's a build artifact, or something more coarse-grained. The fundamental trait of a component is that it's not only describing a provided interface, so what kind of operations and functionality do I provide, but also what is required in terms of like what do I need to actually run, right? There's like even like if you look at or think of classes as a component, dependency injection, especially constructor injection, has kind of applied that componentized thinking to classes, really, right? Because if you express constructor argument, you describe the component, the class's required interface, right? What do I have to feed the class to actually work? Let's zoom out a bit again. What's kind of interesting in an application if you consider a logical component, like what Spring in the Spring universe, what Spring beans, what CDI beans are exposed by a model. That's kind of inspecting all services, all public repositories, all these kind of things. What aggregates are exposed, right? What's the things? What are the things that I can actually get out of the component and apply state transitions to? And what are the events that module publishes, right? So like order created, what have you. On the required side, it's like what other Spring Beans or CDI components do I refer to? Not literally every dependency, but the ones that are crossing module boundaries. What in this case, looking at Spring Boot configuration properties, does the module expose some kind of means of configuring its behavior? That's kind of interesting. And in the equivalent to the published events is basically consumed events. So regarding the events, remember, we have the ability to express that a certain class is an event. So we can actually use all that information that's expressed in the code base to generate, in this case, there's functionality to actually inspect your code base, reflectively inspect the code base, and then extract, find the module annotations, for example, and then create this kind of scope for detecting all the application components in there, and then extract documentation. In this case, it's ASCII doctor format, so that it can actually be rendered to be included into your documentation. So what you see here is the end result. I'm going to see how you actually create that in a second, but looking at the sample code that I've actually prepared for the talk, that's kind of the documentation that would get rendered, in this case, for the customer management, the customer module part. In this case, a module is a package here. So we have like a customer management service there. We have a repository in there. We have a customer aggregate root. And we can even find out that the sample event is actually thrown from the customer init method, like a constructor. Right, and all of this is based on the inspection of the code for jMolecules, annotations, and interfaces, and what have you. Right, there's like Spring configuration properties is a slightly different beast here, and that's why I don't have them in the slides. But you'd get those rendered as well in case you're living in a Spring Boot world. How do you actually generate that? It's 2 lines of code again. There's a documenter API inside Modulith that's kind of associated with jMolecules, and you just point it to your main Spring Boot application class, and then you basically get write documentation. There's 2 different options to be piped in here. One thing that I haven't shown in the slides is that from the module arrangement, from the logical module arrangement of your application, we can also generate package component diagrams and outline the different relationships between the modules, like Spring Bean references across modules or event references across modules. which is kind of helpful. So the former options thing is the one that's used to customize the display of the UML diagram, UML component diagrams, and the canvas options is like other stuff, right? So you can link Java doc and whatnot, and these kind of things. It's all in there. All right. So again, just want to, it's just about like a brief introduction here, right? So I want to get across that if you add this metadata to your code base, not only you get the verification or the ability to verify your code, you can use that to extract documentation that's actually helpful, right? It's not like 500,000 classes and they all appear in a single class diagram, but rather information that kind of reflects on the architectural patterns that you have expressed inside the code base. Right. So the part that you're probably most interested in is the last one, eliminating boilerplate. Who can be against that, right? Or you could not fancy that. So coming back to this example, and like I've spiked already some discussion here, like before. There's a lot of JPA annotations on here, right? And that's kind of expression of like a couple of different sentiments. So the first thing is, you can argue there is a bit of boilerplate induced, right? We need to have a no default constructors. We're supposed to annotate the ID, which is the order ID has to be annotated with embedded ID, so the ID field in order. Order ID has to implement serializable. I think that's not necessarily the case for all JPA persistence providers, but the most common ones. Actually expect that, unfortunately. And again, default constructors, yeah, that kind of stuff. That's kind of technical noise, detail, what have you, right? So one argument to this is, or what are we looking at here? Which we're looking actually at a persistent model. So we have our order model implementation, right? So and that we decided to use JPA right on the actual order aggregate class implementation. That's what I call a persistent model. That's often frowned upon for exactly the reasons that you've just seen, right? That the actual model code gets kind of scattered with persistence details, which is more of a like an understandability thing, because like from a JPA or from an annotation point of view or the dependency point of view, you can still use the order class even without JPA on the class path because it's all annotations. So the suggested alternative by the folks that feel offended by that is to have an actual order class, and then the repository layer is actually or its responsibility is to map that model type into, let's say, a JPA-based class, right? So a dedicated class for persistence, what have you. That approach usually has its advantages, but usually results in a lot of mapping code. And it's either two cases. One is order and JPA order are kind of the same, so it's duplication all over the place, or they're very different, in which case I'd argue, okay, do you want to get into that situation in the first place to have write a lot of complex mapping code? It might have to be if you're not controlling the database schema. But within modern applications where a single application owns the data model, right? It's the same team responsible for the structure of the database tables and the domain code. Then I think there's often even arguments to be made for the persistent model approach from that point of view, right? From the coupling point of view. Let's stick with the left thing, with the left approach first. I just wanted to bring it up because folks always argue, yeah, it's just because you didn't properly implement a dedicated persistence model. Fine. I just see that there's a lot of code out there that basically uses the persistent model approach. And we can actually improve on a lot of problems of that when we're using jMolecules. Because I want to point at one thing here, that a lot of these mappings that we have to define here, and especially I want you to look at the line items thing, the line items property. A lot of these mappings are an implicit expression of the aggregate nature of order. Let that sink in for a moment. If you remember, order was supposed to govern the business rules of the aggregate, right? The order class. So the life cycle of the individual line items is tied to the life cycle of the orders, because how else could order actually govern around the number minimum order amount that I've mentioned before, right? So there is some default mappings that we can assume for example for the relationship from an order to an entity, especially when it comes to lists in this case here, right? So a lot of these mappings, or the fact that we put at JPA entity onto the order class, is kind of a reflection of the fact that order is an aggregate, and by that a DDD entity as well. So it again plays into the notion of we're already using, or we're already expressing these concepts in our code base to some degree, but just not explicitly. So what can we do about this? We can go ahead and start or integrate or use a bytebodymaven plugin that the jMolecules integrations project actually provides. And that bytebodymaven plugin does the following. It knows about the jMolecules concepts that you've expressed in your code base, and it also inspects your class path. So it finds out, oh, you're using JPA because there's a JPA provider on your class path. Similar to what boot does, but at build time in this case, and kind of applying domain kind of rules or architectural pattern rules to your code, and taking the expression of these architectural rules and deriving the technical need or the technically needed means of configuration to your code base. So we can actually, with this in place, we can actually go ahead and remove all default JPA mappings that would need to be applied for aggregates, because we've already expressed that order is supposed to be an aggregate. So we can get rid of, we've expressed that, and we can get rid of entity and the no-args constructor. We can also get rid of the need to implement equals and hash code based on the identifier. Yet another commonly understood thing in the, I need to map my object to a database table, right? So identity or equals and hash code based on the actual key. We can remove @embedded ID. We can remove the default relationship mapping, and we can get rid of the default constructor for the order ID class, and we can even get rid of the fact that we need to implement serializable, because we know we have to do that. So what happens then if you basically remove, if you keep those annotations around, nothing happens at all, right? The jMolecules bytebody plugin kind of respects if you configured any of this manually and just backs off. If you remove the annotations, it will actually add the defaults for you, right? So it adds the default mappings for line items and all this kind of stuff that we just removed. So right. So that's one final thing. I'm just going to go over this quickly because we're running a bit out of time here. For identifier types or for associations to other aggregates, there's even a dedicated type, because it's kind of hard to distinguish. Like if you have multiple fields of multiple fields of type identifier, basically, or of some identifier, then it's kind of hard to distinguish what is the actual entity's identifier and what is the one that's referring to some other entity. In this case, it's obvious because aggregate root is typed to order ID, but assume you have a person that has a list of team members that are also persons, right? Then it's kind of, or person IDs, then it's kind of person ID, and then you kind of lost here. There is a way to make that explicit. So we can define association to a customer via its customer ID, right? So that's association is an interface type, and again, so you can express that in your model, but now you have an interface type that JPA knows nothing about, so you'd actually have to provide a JPA attribute converter, and guess what? That's being taken care of by the jMolecules bytebody plugin. So you can actually, you don't have to care about like getting that persisted. It's just done properly with the generated code. Right. So we basically, to finish this off, we came from the thing on the left. We could scratch away all the things that were that I've struck away here with red, and we've added it's like semantically higher level information to the type system, and then by that, the thing on the right is a completely persistible JPA entity, basically. And what's kind of nice here is you see that add table annotation over there, because order is a reserved SQL keyword, so it would never actually map reasonably. The default mapping wouldn't work. So you actually only add the JPA annotations for the stuff that is not default. Right? So it's kind of like, rather than burying those customizations in between all the things that you need to put there by default. All right. So I hope I could get across that there's benefit in explicitly expressing these architectural concepts, and jMolecules actually being a means to do that. And you don't have to invent these concepts in the first place. They're already like predefined. We've stuck to, or we've been, or no, we have stuck to concepts that we didn't invent ourselves, right? So nobody in the team actually came up with the idea of an aggregate. There's literature, there's an established understanding of what that thing actually is, and the rules between them, basically, right? And then that's why we can actually prepare the concepts and then have tool integration provided to you by so that you can actually get the code that you write using these abstractions run on those certain platforms. There is, for example, there's a jMolecules at service annotation, a jMolecules repository annotation, and the bytebody plugin, for example, would kind of find out, oh, you have Spring on the class bus. It's a Spring application. So we actually also annotate the type at compile time with the Spring at service annotation, and by that make it runnable in a Spring container. I can imagine that the same would work for the CDI environment. I don't think that's available yet, but it's technically doable, right? So you express the architectural concepts, and then there's some integration that kind of projects the ideas that you have expressed onto a technological platform. I'm not sure any one of you is old enough to remember the model-driven development kind of thing, where you had a platform-independent model and then a platform-specific model. I was kind of reminded by that of that process when working on this here. There is, to round things off a third time, there's IDE support already available for IntelliJ. So there's a plugin, jMolecules plugin for IntelliJ that basically just pulls out the stereotypes out of the code base and annotates the package, the tree elements with those. There's even a dedicated node down there, like the jMolecules node, that has the types of a package just grouped by their stereotype. And just recently, we've started the similar development for Eclipse. It's just not there yet entirely. So if you wanted to try that, then you'd have to basically go to the GitHub repo, build it yourself, and install it locally. But we hopefully gets to a release of that pretty soon. All right. jMolecules is about expressing architectural concepts directly in code, so that it fosters understanding. It creates this contextual gravity, so that if you look at a certain piece of code, you kind of immediately know what it is, or kind of at least have to look at less moving parts. There's integration with code verification tools, so that you can verify your model against the rules that come with the concepts. You can extract documentation from that metadata, make use of that to kind of create high-level documentation. And it also allows us to generate boilerplate code that might be necessary at the boundaries of the application when it comes to persistence. that code generation support is not only available for JPA, but also for MongoDB and JDBC, actually. So if you're using Spring Data MongoDB, Spring Data JDBC, then everything just works the same way there. But it's all kind of work in progress, right? So if you're interested, we can just create tickets or whatnot in the bug tracker I have linked here, so that we can like start the discussion and yeah, basically move things forward if you want. There's a GitHub chat, and there's also a couple of books that I can recommend: Simon Brown, George Fairbanks. Here's the Emin Eden and Rick Kasman paper that I mentioned before, and I, to my embarrassment, forgot the names of, but Carola Finin. There you go. So yeah, final shoutouts. Peter Gaffert of ArcUnit. Raphael has been helping me like crazy with the ByteBuddy plugin. Dan Dudkowski has been written the IDEA plugin primarily. Ingo Griebsch is working on the Eclipse plugin. So it's not like this is Ollie's thing here, but it's Henning, Stefan, and me primarily driving this, and the kind folks listed here that help us with all the technical needs. So we have 4 minutes left with 4 questions.
Right. So can you hear me now?
Let me look it up. Hi Gunnar, you're back.
Cannot. So can you hear me, Ollie?
I can hear now.
You can. Okay. Cool.
Sometimes.
Sometimes.
Not always.
But now you can. All right. So there was one question.
Right now I can't hear you, unfortunately.
Ah, damn it. Okay. So let's do like
there's sound again.
How about now?
ByteBuddy. Oh, that's interesting. Play on words here, but I think I've lost you audio-wise. Oh, what do the diagrams look like? Do you have an example? Let me quickly pull one up and move that to my. I didn't have any that actually fit that particular example, but there's a project I do with a local university here in Dresden, and I can, and the reference documentation of that looks. Can I pull this out here? Yep, that works. Jesus, I need to. Oh gosh, what's going on? I'm getting lost here. What's my machine doing? There we are. So it's basically the business modules part of that documentation here. So the diagrams look something like this. There's a package diagram, basically. The individual arrows represent different kinds of references. So a spring bean to a spring bean reference causes a depends on relationship. Uses is basically just I'm referring to, let's say, an identifier type or an entity type of that other module. And the listens to relationship is an event listener in order listen, or the accountancy listening to an event that's published by order. So you see that I mean, that's the overview diagram. You see that already gets slightly complicated if it's more than 4 or 5 modules. There is, however, you can have a flavor of that generated by with an individual module as entry point. So it basically takes the module and shows in the diagram everything that's this thing depends on. So if it's kind of neat, because if I want to understand the inventory, what do I have to do, right? I go here and see, it depends on the other modules. So it's very likely that I somehow have to understand these. And then once I've done that, I can actually go ahead and look at, okay, what are the interesting of that inventory module? What are the interesting entry points? In this case, it's a couple of Spring components, aggregate roots, published events, and events listened to. Let me see if I have a. I don't have an example with properties, but you can see here that we also can link the Java doc that has been published. So that's stuff you can feed into the documentation generation, and then it's kind of connected. So you kind of get this from the top. You can drill deeper just whichever way you like. That's it. I hope that answered the questions. Plans for Kotlin support. Hi Ted, long time no see. I hope we meet again. There's some Spring 1 coming around, I've heard this year. Any plans for Kotlin support? There. Okay, I wonder if you can elaborate on that, because there's nothing that ties this to Java as Java only. So you can use the Java interfaces in your Kotlin classes or the annotations in your Kotlin classes. So there's no specific support yet. And like from a quick thought, I can't really see why that would be necessarily. So to phrase it positively, it should just work with Kotlin. Although the code generation stuff, of course, well, that's kind of, that probably needs a second thought. But like just the expression of those artifact or patterns should be supported already. Size documentation of the rule set then is forced. Yeah, I can recommend the jMolecules integrations GitHub, and it's all in flux a bit. jMolecules integrations GitHub page has a lot of this stuff listed, and I think the page it doesn't have the actual rules listed. Okay, so right now it's a good point. I take that with me. Right now you'd have to look at the jMolecules rules all rule here. All is basically the kitchen sink that you get, but there's, for individual rules, there's individual methods, and they describe exactly what they're verifying. And we're currently working with the JQ system team to like evolve these rules basically in parallel, so that there's kind of consistency between whether you're using ArcUnit or JQ system. All right. Maybe that audio problem is on my end, but I'm kind of wondering.
Yeah.
No.
It is. I just know you can't hear me, but people on stream can hear me.
Yeah, I can now hear you too. Maybe my earbuds just gave up. I can hear you now. That's
okay.
cool.
Awesome. Yeah, it's weird. So that was pretty much it. There's one bonus question for you. What is your opinion on NoSQL? Will it replace SQL?
No, it won't. I've worked on it for like over a decade. It's cool technology. It's useful technology. It's just yet another tool in the toolbox, I think.
Right.
There is, I mean, you can get philosophical here. I definitely think that document-based databases have a bit of an appeal because they align with that notion of an aggregate.
Exactly. Yeah.
Slightly better than relational databases. So it's often easier to just like, oh, I have this aggregate structure, like the order with their line items,
right?
And the impedance mismatch is just way smaller,
yeah,
for those. But they have different challenges. But I can see the appeal of why people look into this.
Yeah,
and, I've seen.
I was always wondering whether not
successfully using them, but yeah. Any plans for Quarkus integration similar to the Spring one? That's one for you, Gunnar, then.
Yeah, I mean,
the first time today, right?
It could be a nice, nice contribution, I guess. So somebody could step up and try to contribute.
Here you are. There you are. So
yeah. So I mean, it could be a nice way for somebody to contribute to jMolecules, right? I think. I mean, it's comparable in terms of the general concepts to Spring Boot. So you could perfectly do this. It's just a question of actually doing it.
Yeah. And I think, I mean, most of it, or a large part of it, would actually like rather work via just generating CDI annotations or what have you.
Right. Exactly.
The JPA stuff would just probably work the same way. Right. And there could be something extra for the, how do you pronounce it, panache or
panache? Yeah,
panache. Okay. Yeah, for that different flavor of persistence. But yeah, I mean, if you have interest, ping me. We can.
I mean, I totally would love to do it. There's just so many things going on. I'm not sure I would find the time.
Awesome. I mean, I was referring to you, of course, but also Raul, if you're interested to see that. Right. Feel free to open up a ticket, and then I can show you around in the way that it's implemented for the Spring side of things, but there's nothing inherently Spring to it. It's just that that's kind of my day-to-day environment. So that's why I try to make it work there first. So,
All right.
all right.
Just looking, I don't see any further questions really. There was a bit of a confusion about what is done by Lombok and what is done by bytebody, but I believe you addressed that.
Yeah, the Lombok. I mean, I'm only using the Lombok annotations for to basically to shortcut my Java code. I totally know that it's a controversial topic. I personally like it quite a bit, but I can understand why someone wouldn't. But the bytebody plugin was basically replacing all the JPA annotations, plus the. I could even get rid of one of the Lombok annotations that was creating the default constructor, because I can let bytebody do that too. So I can, even have less Lombok. It was, I think we ended up with just the value annotation on something, which is kind of handy still for identifiers.
So
But
there's one more question actually. Can we use JDBC instead of JPA?
I briefly mentioned that there is in the integrations, I think it's listed, there is the bytebody plugin that has, not sure it's listed in the technology integration. So that's like the annotation conversation is happening, repository JPA based backed aggregates, and I think the documentation doesn't have it, but persistable implementations for JPA, JDBC, and MongoDB. That's there. It's kind of expecting Spring Data JDBC though, because that has the aggregates to JDBC mapping stuff built into it. So it's not raw JDBC or the plain JDBC APIs there. So it's the Spring Data modules. Also, we need some callbacks for like tweaking the new state and whatnot. So there's a bit of detail going on there, and that's stuff that's only available in Spring Data JDBC, like entity callbacks, similar to what JPA has.
Yeah.
But yeah,
that makes sense. All right, so I believe that's it in terms of the questions. I would say if there's nothing else, thank you, Ollie, so much. This was definitely a very interesting session. I learned a lot about it. It's a great topic. Thanks for being here, and thanks to everybody, of course, for joining the session. And I wish you a very nice remainder of the J Champions conference. See you very soon. Bye-bye.
Yes, well, take care. Bye.